Dear students, welcome. We are solving problems on the innate differentiation. Today, it is our 8th class on this chapter. Let us try to solve some more problems. Problem number 1. If y this is equal to sine inverse x whole square, find y and 0. Find y and 0. We have to find y and when x is equal to 0. Solution. Y this is equal to sine inverse x whole square. Suppose this is number 1. Suppose this is number 1. Differentiating 1 with respect to x we get. Differentiating 1 with respect to x we get. 1 with respect to x we get y1 this is equal to 2 times of sine inverse x 1 by root over 1 minus x square. We will get this one. We shall get this one. This means root over 1 minus x square y1 this is equal to twice sine inverse x. Squaring we get. If you square both sides, then you will get 1 minus x square y1 square this is equal to twice sine inverse x whole square means 4 sine inverse x whole square. You will get this one. This means 1 minus x square y1 square this is equal to 4y. This is equal to 4y. Or 1 minus x square y1 square minus 4y. This is equal to 0. Suppose this is number 2. Number 3. Suppose this is number 3. Differentiate again with respect to x we get. Differentiating 3 with respect to x. Differentiating 3 with respect to x we get 1 minus x square into twice y1 y2 minus twice x y1 square minus 4y1 this is equal to 0. From both sides 2 will be cancelled. Also since y1 is not equal to 0 you may cancel y1 from both sides. 1 minus x square y2 minus x y1 this is equal to 2. This is equal to 2. Suppose this is number 4. Suppose this is number 4. Now differentiate 4 n times by Leibniz theorem. Differentiating 4 n times by Leibniz theorem. 4 n times by Leibniz theorem we get. Leibniz theorem we get. By Leibniz theorem we get 1 minus x square. If you differentiate 2 n times y2, then you will get yn plus 2 plus nc1. Differentiate 1 minus x square, you will get minus twice x. Yn plus 1 plus nc2 into minus 2 yn. From this, if we differentiate the product of this, we will get this. And then you differentiate this by Leibniz theorem. Minus x. If you differentiate y1, then you will get yn plus 1. Since it is a minus sign, therefore nc1 minus nc1. Differentiate x 1, it will be yn. This is equal to 0. This is equal to 0. This means 1 minus x square yn plus 2. This will be minus twice n x yn plus 2 minus x yn plus 2, you will get yn plus 1. You will get this one. No, x into yn plus 1. X into yn plus 1. You will get this one. For this, you will get minus n into n minus 1. N into n minus 1. You will get n into n minus 1. 2 will be cancelled. If you take minus n is common, then you will get plus n yn equal to 0. Plus n yn, this is equal to 0. Yn, this is equal to 0. The 2 will be required. Later. Therefore, I am writing here 1 minus x square yn plus 2 minus twice n plus 1 x yn plus 1 minus, it will be minus n plus n will be cancelled, minus n square yn. This is equal to 0. Suppose this is number 5. Now, putting n equal, x is equal to 0. Putting x is equal to 0 in 1, 2, 4 and 5 we get. Putting x is equal to 0. 1 y equal to sine inverse x whole square. This was 1. Put x is equal to 0. Then you will get y. When x is equal to 0, it is written as y0. y0, this is equal to 0. Since sine inverse x, sine inverse 0, this is equal to 0. Sine inverse 0, this is equal to 0. 1 implies. From 1, you will get this one. Now, from 2, you will get 2 implies. From 2, put x is equal to 0. You will get y10. This is equal to 0. From 2 also, you will get y10. Twice sine inverse 0 divided by 1 minus 0. Therefore, you will get y10. This is equal to 0. Put x is equal to 0 in 4. From 4, you will get y20. This is equal to 2. y20, this is equal to 2. You see, put x is equal to 0. It will be y20. X into y1. It will be 0. This is equal to 2. y2 equal to 0. 5, from 5 you will get yn plus 20. Here it is x, it will be 0. This is equal to n square yn 0. N square yn 0. You will get this. Suppose this is number 6. This is number 6. Two cases arise here. Two cases arise. Case 1. When n is odd, then putting n equal to 1, 3, 5, 7, ... in 6 we get. Putting this is equal to 0, 1, 3, 5, 7, in 6 you will get. Put n is equal to 1, you will get y1 plus 2. This means y30. This is equal to, put n is equal to 1 square y10. y10. This is equal to, now you see here, y10, this is equal to 0. Since y10 equal to 0. y10, this is equal to 0. y50. Put n is equal to 3 here. y50 equal to 3 square y30. y3 square into y30. This is equal to 0. Since y30 is also 0. Since y30 is also 0. Now, y70. Put n is equal to 5 here. y70. 5 square into y50. This is equal to 5 square into y50. This is equal to 0. Since y50, this is equal to 0. This is equal to 0. Thus, you have seen that when when n is equal to 1, 2, 3, y1, 0, 0, y3, 0 equal to 0, y5, 0, this is equal to 0, y7, 0, this is equal to 0. Now put n is equal to 7 in 6, then you will get y90, this is equal to 7 square into y70. y70 is already 0. y90, consequently y90 will be also 0. Similarly, y11 equal to 0 for any odd numbers, for any odd value of n. y10, this is equal to 0. Thus, when n is odd, then y10, this is equal to 0. Perhaps you understand this. y10, this is equal to 0. When n is odd, then y10, this is equal to 0. Means nth derivative of y when x is equal to 0, this is equal to 0. Now we shall consider the case 2. When n is even, then what happens? Case 2. Case 2. When n is even, then putting n equal to 2, 4, 6, 8, in 6 we get. In 6 we get. Put n is equal to 2, 4, 6, in 6 we get. Put n equal to 2 here. Then y4, 0. This is equal to 2 square into y20. y20. This is equal to, since y20 this is equal to 2, y20 equal to 2, you will get 2 square into 2. y60, put n is equal to 4, y60 equal to 4 square into y40. This is equal to 4 square. y40 is equal to 2 square into 2. 2 square into 2. y80, this is equal to 6 square. Put n is equal to 6 there. 6 square into y60. This is equal to 6 square into 4 square into 2 square into 2. You will get this. y80 equal to this. Thus when n is even, then thus when n is even, n is even, then y10, when n is even, then y10, the value of y10 will be equal to, so now see one thing, when y40, it is 2 square into 2. When y60, it is 4 square into 2 square into 2. When y80, 6 square into 4 square into 2 square into 2. y10 will be definitely n minus 2 whole square. This term will be n minus 2 whole square. And the term after that will be n minus 4 whole square, dot dot dot, into 6 square into 4 square into 2 square into 2. When n is even, you will get this one. Thus, we have found that y10, this is equal to 0 when n is odd. When n is even, then y10 equal to n minus 2 whole square n minus 4 whole square, n minus 6 whole square, 6 square, 4 square, 2 square into 2. This is the answer. When n is even, yn 0, this is equal to this. When n is odd, then its value is equal to 0. When n is odd, value is equal to 0. N is odd. y10, 0, y30, 0, y50, 0, y60, 0, and suppose y80. What is y80? Put n is equal to 8 here. What will be this? 6 square into 4 square into 2 square into 2. Answer is this. Answer is y80 equal to 6 square into 4 square into 2 square into 2. y10, 0, this is equal to 8 square into 6 square into 4 square into 2 square into 2. This is the answer. Let us take another example. Let us take another example. Example number 2. Example number 2. If y this is equal to sine inverse x, find yn 0. Y equal to sine inverse x. In the last problem we solved when y is equal to sine inverse x whole square. Now we are going to find yn 0 when y is equal to sine inverse x. Why this is equal to sine inverse x? Suppose this is number 1. y1 this is equal to 1 by root over 1 minus x square. Suppose this is number 2. This means 2 implies you will get root over 1 minus x square into y1, this is equal to 1. Or 1 minus x square y1 square, this is equal to 1. Squaring. Squaring both sides. Squaring both sides, we have got this. Now differentiating, you may write it as number 3. Now differentiating 3 with respect to x. 3 with respect to x. You will get 1 minus x square twice y1 y2 minus twice x y1 square, this is equal to 0. This is equal to 0. You will get this one. This means 2 will be cancelled. Of course y1 these two terms will also be cancelled. This means 1 minus x square into y2 minus xy1, this is equal to 0. Suppose this is number 4. This is number 4. Now differentiating 4, n times by Leibniz theory we get. Differentiating for n times by Leibniz theory we get. Just as usual, 1 minus x square yn plus 2 plus nc1 minus twice x yn plus 1 plus nc2 minus 2 yn minus x yn plus 1 minus nc1 into 1 yn, this is equal to 0. You will get this one. You will get this. This means 1 minus x square into yn plus 2. Here you see this term and this term. Minus twice n plus 1. Xyn plus 1. Xyn plus 1. Minus n into n minus 1 plus n into yn. This is equal to 0. This is equal to 0. This means 1 minus x square into yn plus 2 minus twice n plus 1x yn plus 1 minus n plus 1 will be cancelled. Minus n square yn. This is equal to 0. Minus n square yn. This is equal to 0. Number 5. Now putting these two terms will be required. Now putting x equal to 0 in 1, 2, 4 and 5 we get. Put x is equal to 0 in 1, we get 1. From 1 you will get y is 0, this is equal to 0. Why? Since sine inverse 0, this is equal to 0. From 2 you will get y1 0, this is equal to 1 divided by 1 minus 0, root over 1 minus 0, this is equal to 1. 4 implies y2 0. What will be y2 0? Put x is equal to 0, x is equal to 0, this is equal to 0. 5 implies yn plus 2 0. Put x is equal to 0 here. This term will be cancelled because x is here. This is equal to n square yn 0. Yn 0. Yn 0 means yn, nth derivative of y when x is equal to 0. Yn 0. Suppose this is number 6. Case 1. When n is even, then putting n this is equal to 2, 4, 6, 8, etc. In 6 we get. And this is equal to 2, 4, 6, 8, etc. in 6 we get. y40, this is equal to 2 square into y20. This is equal to y20 is equal to 0. Therefore, it will be equal to 0. Since y20, this is equal to 0. y20, this is equal to 0. Put n is equal to 4. y60. This is equal to 4 square into y40. This is again 0. Because y40, the value of y40 is also 0. Since y40 equal to 0. y80. This is equal to 6 square into y60. Since y60 equal to 0, this is equal to 0. Since y60, this is equal to 0. Thus, when n is even, yn0, this is equal to 0. When n is even, yn0, this is equal to 0. Now, consider the case when n is odd. Case 2. When n is odd. Then putting n this is equal to 1, 3, 5, 7, etc. in 6 we get. And this is equal to 1, 3, 5, 7, etc. in 6 we get. y30, this is equal to n square means 1 square into y10, this is equal to 1. Since y10, this is equal to 1. y50, this is equal to, put n is equal to 3. y50 equal to 3 square into y30. This is equal to 3 square into 1 square into 1. 3 square into 1 square into 1. y70. This is equal to, put n is equal to 5 here. This is equal to 5 square into y50. This is equal to 5 square into 3 square into 1 square into 1. Now, see, when you are finding y70, you get 5 square, 3 3 square, 1 square, 1. When you find y50, then you will get 3 square into 1 square into 1. Therefore, yn 0. Therefore, when n is odd, then yn 0. Yn 0, this is equal to, definitely it will be n minus 2 whole square. Next term will be n minus 4 whole square. Ultimately, you will get 5 square into 3 square into 1 square into 1. When n is odd, the answer is this. When n is even, yn 0, this is equal to 0. When n is even, in this case, yn 0 equal to 0. When n is odd, then yn 0 will be equal to n minus 2 whole square into n minus 4 whole square into n minus 6 whole square, like that, up to 7 square, 5 into 5 square into 3 square into 1 square into 1. This is the answer. Let us take another example. Perhaps you understand this. Perhaps you understand. Let us take another example. Example number 3. If y this is equal to sine of m sine inverse x, find yn 0. Find yn 0. If y equal to sine m sine inverse x, then find yn 0. Y this is equal to sine m sine inverse x. Suppose this is number 1. y1 this is equal to cos m sine inverse x. M divided by root over 1 minus x square. This is number 2. Suppose this is number 2. This means root over 1 minus x square into y1. This is equal to m cos of m sine inverse x. You will get this squaring. Now you square. Squaring we get 1 minus x square into y1 square. This is equal to m square into cos square m sine inverse x. M square cos sine inverse x. This implies 1 minus x square into y1 square. This is equal to m square 1 minus sine square m sine inverse x. You may write like this. You may write like this. This means 1 minus x square y1 square. This is equal to m square into 1 minus sine m sine inverse x. Sine m sine inverse x. What is this? Y. Therefore, this is equal to y square. This will be equal to y square. Now differentiating. You may write like this also. 1 minus x square into y1 square plus m square y square. This is equal to m square. You may write in this way also. M square into y square. This is equal to m square. Now differentiate this. Differentiating 3 with respect to x we get. Differentiating 3 with respect to x we get. Differentiating 3 with respect to x we get 1 minus x square twice y1 y2 minus twice x y1 square plus m square into twice y y1. This is equal to 0. Now 2 will be cancelled. Also y1 will be also cancelled. This means 1 minus x square y2 minus x y1 plus m square y. This is equal to 0. M square y. This is equal to 0. Suppose this is number 4. This is number 4. Now differentiating 4 n times. Differentiating 4 n times by Leibniz theorem. Leibniz theory, we get differentiating 4 n times by Leibniz theorem, we get 1 minus x square y n plus 2 plus nc1, it will be minus twice x, y n plus 1 plus nc2 minus 2 yn. This has been done. Minus x y n plus 1 minus nc1 into 1 yn plus m square yn, this is equal to 0. Yn, this is equal to 0. These two terms will be required. These two terms will be required. Therefore, I am writing here. This means 1 minus x square yn plus 2. Combine these two terms. What will be this? Minus twice n plus 1. X yn plus 1. X yn plus 1. For this, you will get minus n into n minus 1. N into n minus 1. Minus has been taken common. This is minus, therefore it will be plus n. This will be minus m square yn. Minus m square yn. This is equal to 0. Or you may write here 1 minus x square yn plus 2 minus twice n plus 1 x yn plus 1 minus m square minus m square yn. This is equal to 0. Suppose this is number 5. Suppose this is number 5. Now put x is equal to 0 in 1, 2, 4 and 5. Now putting x is equal to 0. Putting x is equal to 0 in 1, 2, 4 and 5, we get 1, 4, 5. 1 implies from 1 you will get y0, this is equal to sin 0, this is equal to 0. Since sin 0 equal to 0, sin 0 equal to 0. From 2 implies y10. What will be this? y10. Cos 0 means 1. M divided by 1. This is equal to m. From 2 you will get m. Cos 0 means 1. M divided by this. 4 implies from 4 you will get y20. This is equal to y20. This term will be cancelled. This term will be cancelled. Minus m square y0. This is equal to 0 since y0 equal to 0. Since y0. This is equal to 0. Also, from 5 you will get. From 5 you will get. From 5 you will get yn plus 20. If you put x is equal to 0, this term will be cancelled. This is equal to m square minus m square yn 0. Suppose this is number 6. Suppose this is number 6. Suppose this is number 6. Now, case 1. When n is even, then putting n, this is equal to 2, 4, 6, 8, etc. In 6 we get. put n equal to 2, 4, 6, etc. in, we get y4 square, 4, 0, this is equal to 2 square minus m square, y2, 0, this is equal to 0. Why? Since y2, 0 equal to 0. Since y2, 0, this is equal to 0. y6, 0, this is equal to 4 square minus m square, y4, 0, this is equal to 0. Since y4, 0 equal to 0. y8, 0, this is equal to 6 square minus m square, y6, 0, this is equal to 0. Since y6, 0, this is equal to 0. Thus, when n is even, then yn 0, this will be equal to 0. When n is even, then yn 0, this is equal to 0. Now we are going to find yn 0 when n is odd. When n is odd. Case 2. Case 2. When n is odd, then putting n equal to 1, 3, 5, 7, etc. in 6 we get. Put n equal to 1 in 6, then you will get y30. This is equal to, you will get 1 square minus m square. y10. What is y10? y10 is equal to m. 1 square minus m square into m. You will get this. y50. 3 square minus m square. y30. What is this? 3 square minus m square into 1 square minus m square into m. M square into m. Now, y70, this is equal to 5 square minus m square. 5 square minus m square. y50, this is equal to 5 square minus m square. What is y50? It is 3 square minus m square into 1 square minus m square into m. Therefore, when n is odd, then yn0, this is equal to n minus 2 whole square minus m square. Next, n minus 4 whole square minus m square. Dot dot dot. And finally we will get 5 square minus m square, 3 square minus m square, 1 square minus m square into m. You will get this. When n is odd, the value of yn0 will be equal to n minus 2 whole square minus m square into n minus 4 whole square minus m square into n minus 6 whole square minus m square into, in this way, finally you will get 3 square minus m square, 1 square minus m square, and whole terms will be multiplied by m. Plus n whole terms will be multiplied by m. And when n is even, then yn0, this is equal to 0. yn0, this is equal to 0. Let us take another example. Let us take another example. Example number 4. If y this is equal to tan inverse x, simply find yn0. Solution. Y this is equal to tan inverse x. Suppose this is number 1. Therefore, differentiating 1, it will be 1 minus x, 1 plus x square. Number 2. This means 1 plus x square 2 implies. This means 1 plus x square into y1, this is equal to 1. Differentiating 3 with respect to x. Differentiating 3 with respect to x. 1 plus x square into y2 plus twice x into y1, this is equal to 0. You will get this one. You will get this. Suppose this is number 4. Now apply Leibniz theorem to find yn plus 2 here. If you differentiate it n times, you will have to apply Leibniz theorem. Now differentiating for n times. Now differentiating for n times. For n times. By Leibniz theorem we get. Differentiating for n times by Leibniz theorem we get 1 plus x square yn plus 2 plus nc1 into twice x yn plus 1 plus nc2 into 2 yn plus 2 times of x yn plus 1 plus nc1 into 2 yn. This is equal to 0. You will get this. This means 1 plus x square into yn plus 2. Now see these two terms. Twice x yn plus 1 is common, and 2 plus 2 times of n plus 1. Am I right? X yn plus 1 twice nx plus twice x n plus 1. Yes, this term. And for this n into n minus 1, it will be n into n minus 1 plus n into n minus 1 plus twice n into yn. This is equal to 0. This means 1 plus x square into yn plus 2 plus 2 times of n plus 1x yn plus 1 plus n square plus n plus nyn. This is equal to 0. Or you may write here 1 plus x square into yn plus 2 plus 2 times of n plus 1x yn plus 1 plus n into n plus 1 yn. This is equal to 0. This is equal to 0. You will get this one. Suppose this is number 5. This is number 5. Now, these two terms will be required. Therefore, I am writing 4 will be also required. Putting x is equal to 0 in 1, 2, 4 and 5, we get 1 implies y0, this is equal to 0 because tan inverse 0, this is equal to 0. y0, this is equal to 0 because tan inverse 0 equal to 0. Since tan inverse 0, this is equal to 0. Tan inverse 0 equal to 0. From 2 you will get y10. This is equal to, put x is equal to 0 here. 1 by 1 plus 0. This is equal to 1. This is equal to 1. From 4 you will get, 4 implies y20. What will be y20? X is, if you put x is equal to 0, x is equal to 0. y20 is equal to 0. Finally, from 5 implies, from 5 you will get yn plus 2, 0. This is equal to this term will be vanish, this term will vanish, because if you put x is equal to 0, this term will be vanish. This is equal to minus n plus 1 into n, yn 0, yn 0. Suppose this is number 6. Suppose this is number 6. Now, case 1, when n is even, then case 1, when n is even, then putting n equal to 2, 4, 6, 8, etc. in 6 we get. Putting n equal to 2, 4, 6, 8, etc. in 6 we get. Y for 0, this is equal to minus, what will be this? 3 into 2 into y to 0. This is equal to 0. Since y to 0 equal to 0. Since y to 0, this is equal to 0. Since y to 0, this is equal to 0. Now put n equal to 4, y6 0. This is equal to minus 5 into 4, y4 0. This is equal to 0. Since y4 0 equal to 0, since y4 0, this is equal to 0. Similarly, y8 0 equal to 0. This is equal to 0. y10 0, this is equal to 0, and so on. Therefore, when n is even, then yn 0, this is equal to 0. When n is even, then yn 0, this is equal to 0. Case 2. When n is odd, case when n is odd, putting n equal to 1, 3, 5, 7, etc. in 6 we get. In 6 we get. You put y3 0. This is equal to what? Minus 2 into 1, y1 0. Put n equal to 1. Minus 2 into 1, y1 0. What is y1 0? This is equal to 1. Into 1. This is equal to 1. y5 0. Next, you see y5 0. What will be y5 0? Put n is equal to 3. 4 into 3, y3 0. This is equal to minus 4 into 3. What is y3 0? Minus 2 into 1. Into 1. You will get this. y5 0 equal to this. y7 0. This is equal to minus, put n is equal to 5, you will get minus 6 into 5, y5 0, put the value of y5 0, minus 6 into 5, minus 4 into 3, minus 2 into 1, into 1, you will get this. When n is odd. Now, notice this step. When y30, we got minus 2 into 1 into 1. Minus 2 into 1 into 1. If you count from right hand side, 1 into 2. From y50, you got, omitting the minus sign, you will get 1, 2, 3, 4. Means 1 less than 5. Up to 1 less than 5. 1, 2, 3, 4. When you are finding y70, omit the negative sign, minus sign. Then you will get 1, 2, 3, 4, 5, 6. Up to 6. Similarly, y90, what will be y90? y90, this is equal to minus 8 into 7. Next time you will get minus 6 into 5. Next time you will get minus 4 into 3. Next time minus 2 into 1. And finally 1. Now see, first you omit the minus sign. Then you will get 1, 2, 3, 4, 5, 6, 7, 8. If you are evaluating y90, then omitting the minus sign, you will definitely get factorial n minus 1. Factorial n minus 1. Now question is this, how many minus 1 is there? How many minus sign is there? In y90, in y70, in y50, and in y30. In y30, there was only one minus sign. In y50, there was two minus sign. In y70, it was three minus sign. In y90, it was four minus sign. Therefore, proceeding in this way, we shall ultimately get y0, this is equal to minus 1 whole to the power. We shall write after some time. And it will be definitely 1, 2, 3, 4 up to 8 for y9, for y7 1, 2, 3, 4 up to 6, for y5 1, 2, 3, 4. Therefore, it will be definitely 1 into 2 into 3 into up to n minus 1. It will be definitely this. From right hand side, you see 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6 up to n minus 1. For n, if you are evaluating y and 0, you will definitely get this. Now, question is this. Minus 1, you see, for y5, there are two minus sign. Minus 1 whole square. For y7, minus 1 whole cube. For y9, minus 1 whole to the power 4. 2, 3, 4. For y11, it will be minus 1 whole to the power 5. 11 minus 1 whole to the power 5. Now guess. For y and 0, minus 1 whole to the power what? You see, you are evaluating when you are evaluating y50, minus 1 whole square. This can be written as minus 1 whole square. This can be written as 5 minus 1 divided by 2. It will be 2. For y7, minus 1 whole cube, it means 7 minus 1 divided by 2. y90, 4 minus sign is there. Minus 1 whole to the power 4. This means minus 1 whole to the power 9 minus 1 divided by 2. You may write like this. Definitely, for y0, it will be n minus 1 divided by 2. N minus 1 divided by 2. N minus 1 divided by 2. Which is equal to minus 1 whole to the power n minus 1 divided by 2 into factorial n minus 1. Into factorial n minus 1. It will be like this. It will be like this. Thus, when n is even, y0, this is equal to 0. When n is odd, then y0, this is equal to minus 1 whole to the power n minus 1 divided by 2 factorial n minus 1. You will get this. When n is even, y0, this is equal to 0. When n is odd, then y0, this is equal to minus 1 whole to the power n minus 1 divided by factorial n minus 1. Perhaps you understand. Now, so far we are solving problems and we are evaluating y0. In each case, you perhaps notice that y0, this is equal to 0 in either of the two cases, when n is even or n is odd. Now, I am going to solve a problem for which both are not 0. For which, so far we have done 4 problems. In 4 problems, either when n is even or n is odd, y0 is equal to 0. In one of the two cases. And now we are going to solve a problem for which y0 is not equal to 0 for both the cases when n is even or n is odd. Let us take the problem. Let us take the problem. Problem number 5. If y equal to e to the power a sin inverse x, find y0. E to the power a sin inverse x, find y0. Why this is equal to e to the power a sin inverse x? Suppose this is number 1. This means y1, this is equal to e to the power a sin inverse x. A divided by root over 1 minus x square. Suppose this is number 2. This means y1, this is equal to a into y divided by root over 1 minus x square, or you may write 1 minus x square into y1. This is equal to ay now square. 1 minus x square into y1 square, this is equal to a square into y square. This is equal to a square into y square. Suppose this is number 3. Differentiating 3 we get differentiating 3 we get 1 minus x square twice y1 y2 minus twice x y1 square. This is equal to a square into twice y y1. This means 2 cancel. Since y1 is not equal to 0, this is cancelled. 1 minus x square y2 minus x y1. This is equal to a square y. Suppose this is number 4. Suppose this is number 4. Now differentiating four n times, differentiating 4 n times, we get n times. Definitely we will apply Leibniz theorem. We get 1 minus x square y n plus 2 plus NC1 minus twice x, yn plus 1, plus NC2 minus 2 yn, minus 2 yn, minus x yn plus 1, minus NC1 into 1 yn. This is, or minus a square yn. This is equal to 0. This is equal to 0. Or 1 minus x square into yn plus 2. What will be this? Minus twice n plus 1 into x yn plus 1. It will be minus n into n minus 1 plus n plus a square yn. This is equal to 0. Or 1 minus x square into yn plus 2 minus twice n plus 1 x yn plus 1 minus plus and minus n will be cancelled, n square plus a square yn. This is equal to 0. Suppose this is number 5. Number 5. Putting x is equal to 0 in 1, 2, 4 and 5, we get from 1 y is 0. This is equal to e to the power a sin inverse 0. This is equal to e to the power 0 equal to 1. This is equal to 1. From 2 y 1 0. This is equal to, this is 1 a divided by this. It will be a. It will be a. 4 implies. Put x is equal to 0 here. It will be y to 0. This is equal to a square into y 0. This is equal to a square into 1 equal to a square. Now see, y1 0 equal to a, y2 0, this is equal to a square. 5 implies yn plus 2 0. This is equal to, here 5 implies this term will be equal to 0. This is equal to n square plus a square into yn 0. Suppose this is number 6. This is number 6. Suppose this is number 6. Now, case 1. When n is odd, putting n equal to 1, 3, 5, 7, ... etc. in 6 we get 1, 3, 5, 7, etc. in 6 we get y30. This is equal to, put 1 square plus a square y10. What is y10? This is equal to a. 1 square plus a square into a. y50. This is equal to 3 square plus a square y30. From here substitute the value of y30, 3 square plus a square, 3 square plus a square into 1 square plus a square into a y70, 5 square plus a square into 3 square plus 5 into y50. This means y70. This is equal to 5 square plus a square into 3 square plus a square into 1 square plus a square into a. You will get this. you will get this. Now, does when n is odd, then y and 0, what will be this? N minus 2 whole square plus a square. Next term will be n minus 4 whole square plus a square, dot dot dot. And finally we will get 5 square plus a square, 3 square plus a square, 1 square plus a square, and the final whole terms are multiplied by a. 1 square plus a square. These terms are all a square multiplied by. This is one answer. When n is odd, then y and 0, this is equal to n minus 2 whole square plus a square plus into n minus 4 whole square plus a square into n minus 6 whole square plus a square. Finally, 5 square plus a square into 3 square plus a square into 1 square plus a square into a. Case 2, when n is odd, when n is even. Case 2, when n is even. When n is even. When n is even. Let's see. When n is even. Putting n equal to 2, 4, 6, etc. in 6 we get. In 6 we get y40. This is equal to, put 2 here, 2 square plus a square into y20. What is y20? Is equal to a square. This means this is equal to 2 square plus a square into a square. y60. This is equal to 4 square plus a square. y40. This is equal to 4 square plus a square. What is y40? 2 square plus a square into a square. y80. This is equal to 6 square plus a square. y60. This is equal to 6 square plus a square into 4 square plus a square into 2 square plus a square into a square. You will get this. 2 square plus a square into a square. You will get this. Does, when n is even, then y and 0, then I am writing when n is even, then when n is even, then y and 0, this is equal to n minus 2 whole square plus a square. Next term will be n minus 4 whole square plus a square. Next term will be n minus 6 whole square plus a square. Like that. Dot dot dot. 6 square plus a square. 4 square plus a square. 2 square plus a square into a square. Into a square. This is another answer. When n is even, then y and 0 equal to this. Last term is a. 1 square plus, last before term is 1 square plus a square, and then 3 square plus a square. When n is even, when n is odd, this, when n is even, then a square, 2 square plus a square, 4 square plus a square, like that. Perhaps you understand this. Let us take another problem. If y equal to half of 10 inverse x whole square, then prove that Then prove that yn plus 2 0 plus twice n square yn 0 plus n into n minus 1 whole square into n minus 2 yn minus 2 0. This is equal to 0. We have to prove this one. Let's solve solution. Why this is equal to half of tan inverse x whole square. Differentiating, suppose this is number 1. Differentiating 1 with respect to x. Differentiating 1 with respect to x. You will get y1, this is equal to half into 2 times of tan inverse x into 1 by 1 plus x square. 1 by 1 plus x square. This means y1, this is equal to tan inverse x divided by 1 plus x square. This means 1 plus x square into y1. This is equal to tan inverse x or 1 plus x square whole square. y1 square, this is equal to tan inverse x whole square. This means 1 plus twice x square plus x to the power 4 into y1 square. This is equal to tan inverse x whole square will be equal to twice y. Suppose this is number 2. Now differentiate 2 with respect to x. Differentiating 2 with respect to x, we get 2 with respect to x, we get. Differentiating 2 with respect to x, we get 1 plus twice x square plus x to the power 4 twice y1 y2 plus 4x plus 4x cube y1 square. This is equal to twice y1. This means twice y1 will be cancelled. 1 plus twice x square plus x to the power 4 into y2 plus 2 times of x plus x cube y1. This is equal to 1. This is equal to 1. Now differentiate n times by applying Leibniz theorem. Differentiating 3. Now differentiating 3 by Leibniz theorem we get. By Leibniz theorem we get. Now I am writing in that side. By Leibniz theorem, just differentiate this. By Leibniz. 1 plus twice x square plus x to the power 4 yn plus 2 plus nc1. Differentiation of these 4x plus 4x cube yn plus 1 plus nc2 4 plus 12x square yn plus nc3 24x yn minus 1 plus nc4 24 yn minus 2. Up to this we have differentiated by Leibniz theorem plus this term. Now we are going to apply Leibniz theorem plus 2 times of x plus x cube yn plus 1 plus nc1. If you differentiate this will be 2 into 1 plus thrice x square yn plus nc2 differentiate this 6x yn minus 1 plus nc3 into 6, not 6, it will be 12, 6x into 2, 12x, it will be 12 into yn minus 2, this is equal to 0, am I right? 2 times of this, differentiate yn plus differentiate this 6x into 2, 12x, 12, yes, I am right. Suppose this is number 4, we have to prove that yn plus 0, yn 0, yn minus 2 0, therefore put x is equal to 0 in 4, putting x is equal to 0 in 4, we get, putting x is equal to 0 in 4, we get, if you put x is equal to 0, 1 into yn plus 2 0, yn plus 2 0, this term will be 0, plus 0, this term will be 0, plus nc2 into 4, yn 0, plus 0, since it is x 0, plus nc4 into 24, yn minus 2, n minus 2 0, plus this term will be 0, plus n into 2, yn 0, this term will be 0, plus nc3 into 12, yn minus 2 0, this is equal to 0. Perhaps you understand this. Now, x is equal to 0 into, we have got this one. Now I am writing. I am bringing here. This means yn plus 2 0 plus n into n minus 1 divided by 2 into 4 yn 0 plus n into n minus 1 into n minus 2 into n minus 3 divided by factorial 4 into 24 into yn minus 2 0, yn minus 2 0 plus twice n yn 0 plus n into n minus 1 into n minus 2 divided by factorial 3 into 12 yn minus 2 0, this is equal to 0, Now I am writing here, this means from here I am writing this, yn plus 2 0 plus, what will be this? 2 times of n into n minus 1, yn 0, factorial 4 means 4 into 3 into 2, 24, factorial 4 will be cancelled, plus n into n minus 1 into n minus 2 into n minus 3, yn minus 2 0, yn minus 2 0 plus twice n yn 0 plus, what will be this? Factorial 3 means 6, it will be 2 times of n into n minus 1 into n minus 2 yn minus 2 0, this is equal to 0, now let, what will be the next term? Yn plus 2 0 plus, just combine the terms involving yn 0, twice n common, yn 0 common, you will get twice n into n minus 1 plus 1 yn 0 plus n minus 1 n minus 2 n minus 1 n minus 2 common, yn minus 2 0 also common, n into n minus 1 n minus 2 common, n minus 3 plus 2 yn minus 2 0. This is equal to 0. n minus 2 0, this is equal to 0. This means yn plus 2 0 plus minus 1 plus 1 cancel, twice n square into yn 0 plus it will be n minus 1. Already n minus 1 is there. n into n minus 1 whole square into n minus 2 yn minus 2 0. This is equal to 0. Yn minus 2 0. This is equal to 0. You see, this has been proved. This has been proved. Dear students, I am going to stop here. I want to stop here. We shall meet in the next class. Thanks for attending the class. Thank you very much. Thank you.